Hello guys, this is Matt Spread from the Erudite Tutorials, and we are back again and we are taking up an interesting topic from functions, which is the invisible function, or will I say an interesting aspect of functions. Now, we are making this video on the assumptions that you have basic idea on what functions, domain and range it's all about. But if you don't, not to worry. Let's just take a quick recap on what function is. Now, I want us to think of function as a vending machine. And for you to access a vending machine, you need a coin to get whatever package you want. Now, we can call the coin the domain or the independent variable. It is called independent variable because it's always the first entry in the function. Take note. Take a look at the vending machine. The coin goes in first. Only afterward you can have your package. So the package can be seen as your range, which is the second entry. Yeah, the package is the second entry of a function. The range is a function of the domain, so therefore its value is dependent on the domain. That is why it's called the dependent variable. So here, y is a function of x is the domain, y is the range. That is how it's been represented. Y, it's always the range, and x is the domain. Y is always your second entry, and your x is always your first entry. Now, let's take a quick example on the function based on recap. Then we'll jump right into inverse of a function. But let's say we have this question: if a function x is equals to 2x plus 1, find the range of the function if 3 is the domain. Now, how do we tackle this? Now, since we know that the range is a function of the domain, which is y, is a function of x, as we have said earlier on, it simply means that y is a product of what x has to offer. The value of y is dependent on what x is, so that's why it is written as y is a function of x. And we know what our x is. Our x is obviously 3 because 3 is the domain. So what do? We just put it right into the equation and solve directly. Now y must be equals to 2x plus 1. Why must y be equals to 2x plus 1? Because that is the function. So the product of the function is equals to the range. Now function 3 is equals to 2 into bracket, substitute right in 3 into the equation, and you have 2 into bracket 3 plus 1, and function 3 is equals to 6 plus 1, and function 3 is equals to 7. Now that's how we've tackled this question. So enough of recap, let's jump right into the business of today, which is inverse of a function. It has been established that y is a function of x. Now if we try to look at the inverse of a function, it becomes x is an inverse function of y. I'll explain. Now, inverse of a function just simply means interchanging the first and the second entries. You are making the first entry become the second, and making the second entry become the first. So now, what we do in inverse of a function is that we try to rearrange or try to rewrite the functional equation in a way that makes y independent and makes x dependent on y. Yeah, so x is the inverse function of y. So y is the domain of an inverse function. Yeah, that's what it means. Y becomes the domain of the inverse function, and x becomes the range of the inverse function. Let's find the inverse of this function. G function x is equals to 8x plus 3. F function x is equals to sine x plus 1. And f function x is equals to 1 all over x minus 2. Today we're going to be tackling 2 of these questions, and we'll let you do the last one, but not to worry, we'll post the answer at the end of this video so you can check if you're correct. Let's jump right in. For the first one, g of x is equals to 8x plus 3. Now, I said earlier that when we're trying to find the inverse of a function, we're trying to rearrange the functional equation in such a way that it makes y the domain and makes x the range. So, in other words, we're just trying to make x the subject of the formula. G of x is equals to 8x plus 3. So all we're trying to do is to make x the subject of the formula. Now we know that y is equals to g of x, and because y is equals to g of x, y is equals to 8x plus 3. Now we try to make that equation y is equals to 8x plus 3 subject of the formula. So it becomes y is equals to 8x plus 3. Now what do? 3 is a constant. We take it to the other side, and if it has a negative sign, it becomes 8x is equals to y minus 3. Now what else do? We divide both sides by the coefficient of x, and the coefficient of x there is 8. So x is equals to y minus 3 over 8. That's the inverse of this function. Now we have just made x the subject of the formula. How do we represent it? We write it as x is an inverse function of y, which is equals to y minus 3 over 8. Or it can be represented as x is an inverse function of x, which is equals to x minus 3 over 8. Now you can represent it in both ways. They still mean the same thing, but most of the time the second is what you see more in your textbooks. Now let's look at the second function, which is function x is equals to sine x plus 1. This will try to make x the subject of the formula. Y is equals to function x. Y is a function of x, obviously. So y is equals to sine x plus 1. Now we try to make x the subject of the formula by taking 1 to the other side. When positive 1 goes to the other side, it becomes negative 1. So we have sine x is equals to y minus 1. Now, trying to make x the subject of the formula, we take sine to the other side. When sine crosses the equality sign, it becomes x is equals to sine inverse of y minus 1. So you put both of them in a bracket. So we have just made x the subject of the formula. So it is represented as x is equals to function inverse of y, which is equals to sine inverse of y minus 1, all in bracket, or x is equals to function inverse of x, which is equals to sine inverse, all in bracket, x minus 1. Yeah, so with this we have come to the end of this video. We promise to post the answer of the last question, so you try and check if you're correct, and this is the answer. Yeah, so don't forget to like and subscribe, and let me know what you think about this in the comment section below. Thank you.